In how many ways can a committee of 5 be made from a pool of 5 boys and 6 girls if the first case, no restriction, that means in all we have 11 people out of which 5 have to be selected. The answer is quite simply 11C5. The team must have 2 boys and 3 girls. That means out of 5 boys, 2 have to be selected. Out of 6 girls, 3 have to be selected. And the 2 actions are happening simultaneously. So it's about a multiplication sign. Always remember, and means multiplication or means addition. So 2 out of 5 boys and 3 out of 6 girls, that means the sign has to be of multiplication. Team must have at least 1 boy. A smart way of solving this would be to look at the total number of cases and from this subtract the case when there is no boy, all are girls. Total cases minus all girls. That means out of 6 girls, 5 are being selected. This would be the right answer. Another way would be that you first find the case for 1 boy. That means 5C1 and 4 girls plus 2 boys, 3 girls likewise until all 5 boys, so 5C5. But this would of course take much longer. Answer would be the same. This is a smarter way of doing it. Look at this one. The team must have at the most 4 boys. At the most 4 means the cases of 0 boys, 1 boy, 2 boys, 3 boys and 4 boys, which means 5C0 into 6C5. This case would be 5C1 into 6C4, 1 boy and 4 girls. This case 2 boys, 5C2 and therefore 3 girls. And this case is 3 boys and therefore 2 girls. And this case is 4 boys and therefore 1 girl. And all the cases of course need to be added. This approach would be of course time consuming. A better way of doing this would be to find the total number of cases out of which you subtract the case of more than 4 boys. There's only one such case where all the 5 boys are selected and no girl is of course selected. Total cases 11C5 minus 5C5 is 1. So this would be a smarter way of solving this question. Next question, a particular girl is always selected. That means now we have 10 boys and girls remaining, out of which 1 girl has already been selected. So out of the remaining 10, 4 need to be selected. That's the answer. Next, 2 particular boys are never selected. That means the pool reduces to 9. 5 plus 6 minus 2, 9, out of which 5 need to be selected. That's the answer. Look at this one. There will be 2 cases. One is that Jack is selected and Lily is also selected, and the other case would be when Jack is not selected. Remember, in such cases Lily can still be selected. In this case 2 people have already been selected, so it's about out of the other 9 people 3 being selected, or in this case when Jack has not been selected, then out of the other 10 people any 5 can be selected including Lily. The answer would be 9C3 plus 10C5. Look at this one now. This again would have 2 cases. Either both are selected or both are not selected. If both are selected, then out of the other 9, any 3 can be selected. And if both are not selected, then out of the other 9, 5 have to be selected. The answer would be 9C3 plus 9C5. A very important slide, this one. If you can solve all these questions, you have a very fine grasp on the basics of combinations. This was the concept, guys. GMAT shorts are deliberately kept brief. For an elaborate explanation, please refer the stage 1 videos. Thanks for watching.